why you're most likely struggling with inequalities. The first reason could be you're misunderstanding mathematical symbols. Speaking of mathematical symbols, each one means something a little different. For example, this sign is the less than or equal to sign. When you see an equality symbol underlined, it will always be equal to in some shape or form. Or the answer could be less than. So either way you put an answer, you're going to be fine. And then the second symbol is the less than sign. The third symbol is the greater than or equal to symbol. The fourth symbol is the greater than symbol. So the second one and the fourth one you've most likely seen in elementary school. The first one and third one are new ones we add when we're doing algebraic inequalities. They're nothing to be afraid of and they're not bad as they sound. They just have a greater meaning, which would be the equal to part. So when you're writing your answer, it can be less than or greater, but it could also be equal to your given. The second reason you're probably struggling is your negatives are messing up the flow of the equations. So believe it or not, when I was learning these new math topics, the negative sign constantly messed me up, and that's why I would get the answer wrong. When we do a few examples, we would do an equation regarding the negative and how to prevent error. The third reason would be not treating them like equations. What you do on one side of the inequality, you would do to the other, like adding or subtracting a number. This idea is commonly expressed in one-step equations and two-step equations. Now, you're probably wondering, what are inequalities? In short, they are comparing values, they show a range of answers, and they use inequality symbols, like the ones we went over in the previous spiel. But for a more technical definition, it is a mathematical expression that shows a range of possible outcomes for a numerical value rather than a single solution. But there are some things to know about inequalities before we go any further. You're going to solve them like equations. So we mentioned earlier this for a common mistake when solving equations, just think of a one-step or two-step equation just with different symbols. So if needed, add or subtract on both sides, which we will do an example later on. The second thing to know is flip the negatives. It's not as bad as it sounds. What it truly means is when you're multiplying or dividing both sides of an inequality by a negative number, you must reverse the direction of that sign. So we will go over that in an example as well because it goes with the negative in a way. They go hand in hand. So when dealing with the negative inequality, just keep in mind you treat them a little bit differently than you would a ordinary inequality, which would be a positive inequality. And the third thing to know is the answers are ranges. So essentially they show a wide and possible outcome to what the answer could be. It shows infinite solutions, not a set number you get like when you are working with a one-step or two-step equation. Inequalities show a range of answers, different possibilities of what an answer could be. So you could have multiple answers and they could be correct. Now we can jump in and solve. So for example number 1, I have x plus 2 is greater than 5. To solve, I'm going to subtract 2 on both sides to isolate that variable. That alone gives me my answer since x is isolated. But now, this is just the stepping stone. So, I don't have to do any subtraction now or addition because I already solved this like an equation would be. But this x is not the full resolution. 3 is not the full resolution. So since this is inequality, it's a range of answers, right? So as long as my x is less than 3, x can be any number. I could have 1 plus 2 is less than 5. I could have 2 plus 2 is less than 5. I just have to make sure. I can even be a negative number, like negative 1 plus 2 is less than 5. It is a infinite amount of solutions. So they just have to be less than 3. I could plug any number into that x and it can be less than 3. So whatever you put is it's a good answer just as long as it's less than 3. For example, number 2, I have 3x is less than 12 or equal to 12. To solve, I want to have x by itself. So I'm going to divide 3 on both sides of the equation to cancel out that 3x and have x by itself. Now that that x is isolated, I'm going to drop down the inequality symbol as well. So when I solve 12 divided by 3, I have 4. So x is less than or equal to 4. So what that is really saying, once again, is that range. I could put any number as long as it's less than or equal to 4. I could even put a negative number or a simple 4. For example, number 3, this one deals with the negative symbol, which we see that negative 7x, right? So like I mentioned earlier. So keep in mind there is a negative sign. So that means we're going to flip that inequality sign eventually. And do not let that scare you, because earlier I said that when you're dealing with a negative inequality, you're going to treat it a bit more differently. And in this case, we are. We're flipping that inequality sign of negative 7x is less than or equal to 63. Okay? So just keep that in mind, that negative sign. So to solve, I'm going to divide negative 7 on both sides to get that x by itself. When I do that, I have x is less than or equal to negative 9. But wait. When dealing with the negative, you're going to flip that sign the opposite way. So I'm going to flip that less than or equal to a x is greater than or equal to negative 9, because when you're dealing with inequalities with a negative symbol, you're going to have to flip them. That's all that means, because it makes that positive. There's like another reason for that, but just keep it short and simple. When you're dealing with the negative, just flip the inequality symbol to the opposite direction. So when I do that, I have x is greater than or equal to negative 9. So I could put any number for x as long as it's greater than or equal to 9. So I could negative 9. So I could put 10, positive 3, and stuff like that, because the answer would be greater than and or equal to negative 9. So now that you know these, you now know why inequalities can be confusing. And once we figure out the confusion part, you can move on to the solving part and practice, because now we don't have that roadblock. So we can jump to the big idea now. The big idea is you can solve inequalities the same way you solve equations. We did that. We were able to isolate and divide, subtract, and add when needed, just like we would a one-step or two-step equation. So you just solve them the same way you solve equations. That's why inequalities aren't that big or scary to deal with. They are more simpler than you think. Just remember that dealing with negatives is important because a rule comes into play. You flipping that inequality that opposite way. So, thanks for watching. Ari the Math Tutor, signing out.